Hi students, all of you welcome. Welcome to Sunil Engineering Academy. I am Sunil Kumar Bandaru. Students, in this power systems through topic wise MCQs, we have already completed 7 sessions. It is the 8th one. Okay. If you still not subscribed this channel, please click on subscribe button. And if you want previous sessions, click on playlist. You can find out all the previous sessions. Okay. And if you want a PDF, then you can visit sunilengineeringacademy.com. From that you can download the electrical engineering PDF notes. Okay. And you can also join the Telegram group. Let us start the session, guys. So now we are going to start the very important topic in the power systems, that is corona. Okay. So let us take a first question. Corona is accompanied by dash. Accompanied by dash. So how we can get the idea? There is a corona. Okay. So what is the corona in the simple terms? Whenever the operating voltage is greater than critical disruptive voltage, then if it is a conductor, the air around the conductor is going to be ionized due to the very high voltage. The air around the conductor is ionized. Whenever the air around the conductor is ionized, then current also flow through that air. Correct? Current also flow through that air. That means the dielectric strength of the air is going to be break. So that's why some amount of current also flowing through the air. Okay, so whenever that current is flowing through the air, we will get the hissing sound and vibration. Okay, if the voltage further increases, we can also get the visible light and ozone gas production. Okay, due to this, we are getting the losses. We are getting the power losses and radio interference. So we can get all this. So corona is accompanied by all of the above. Okay. Simply guys, whenever we are getting some hissing sound and noise, you can simply say that is due to corona. Why? Because the air around the conductor is going to be ionized. Why? Because whenever the operating voltage is greater than VD, then only corona occurs. Then only corona occurs. Whenever operating voltage is less than disruptive voltage, then no corona. No corona losses. Okay, coming to the next question. Current drawn by the line owing to corona loss is dash. Whenever there is a corona concept, then current also flowing through the air, then it loses its sinusoidal. Okay, so it will become non-sinusoidal. It becomes non-sinusoidal. Corona loss can be reduced by use of hollow conductors because of dash. Because of dash. Here we know disruptive voltage VD is equal to GMR delta ln of D by R. Okay, ln of D by R. Coming to the power loss due to corona. Coming to the power loss due to corona. So here we have the formula for power loss due to corona, 241 into 10 power minus 5 into F plus 25. F is the frequency, delta is the air density factor, root R by D, V phase minus VD whole square. Okay, V phase minus VD whole square. So here, whenever this VD is somewhat of more, VD is somewhat of more. So that is negative part is more. Whenever the negative part is more, then power loss will be less now. So power loss will be less due to corona loss will be less. This is the very important guys, very important. As negative term is increases, the power loss due to corona will be decreases. So here as the radius increases, what will happen as the radius increases? VD is increases. As VD increases, we know the power loss due to corona loss will be decreases. Okay, so that's why whenever the voltages is greater than 400 kilovolts, especially you can say extra high voltages. In this case, the size of conductor depends on corona, depends on corona. Okay, so whenever we will take some high radius, then power loss due to corona will be less. So if you can consider standard if you can consider solid conductors and hollow conductor having some high radius for the same effective area, it having some high radius. So due to that, the power loss due to corona will be decreases. Okay, so here you can say that for a given cross section, the radius is increased, radius is high. Okay, so that's why power loss due to corona loss will be less. But hollow conductors having limited advantages. Why? Because if you want to make it coil is somewhat of difficult. So handling transportation is difficult. Mechanical strength is very less. So that's why hollow conductors are not preferred in the transmission lines. But in case of substations, whenever we require a small length of the conductor in the substations, then we can go with the hollow conductors. Okay, so hollow conductors are preferred in the substation. That is also a very important question. Okay, now coming to the next one, corona loss is dash on hilly areas than plain areas. Corona loss is dash on hilly areas than the plain areas. Corona loss are more on hilly areas than the plain areas. So it will comes into atmospheric terms. You know very well, coming to air density factor is 3.92 H by T plus 273. H is the pressure. H is pressure. Okay, so we know very well, as the height from the earth surface is increases. What about the pressure? What about the pressure? Pressure is going to be, as the height increases from the earth surface. What about the pressure, guys? So pressure is generally going to be decreases. As the pressure is going to be decreases means H is decreases. So delta is going to be decreases. Okay, as the delta is going to be decreases. As delta decreases, Vd is equal to GMR delta ln of d by r na. So as the delta decreases, Vd decreases. We know very well, power loss due to corona is inversely proportional na. So as Vd decreases, power loss is going to be increases. So that means more in the hilly areas than the plain areas. Okay. So as the height from the earth surface increases, pressure is going to be decreases. Okay, that's why it is very difficult to cook in the mountains. It is difficult to write by using the pen in the aeroplane. Okay, why? Because as pressure is less, ink may be leaks. Okay, that is a very important physics question. Okay, as the height from earth surface increases, pressure is going to be decreases. Okay. So here, as Vd decreases, power loss will be increases. So higher in the hilly areas. Okay. Coming to the next one. Due to humid weather, the corona loss will be dash. Due to humid weather, bad weather, in case of snow, in case of dust, in case of ice, fog, not a forge, case of fog, and in case of raindrops, whatever it may be. Due to this, what about the irregularity factor? Irregularity factor is decreases. Why? Because it becomes more irregular. More irregular. Okay. So for example, if it is a conductor, if the rain drops fall on that one, then it will becomes more irregular. If it is a more irregular means M is less. As M is less, what about the Vd? Vd is equal to GMR delta ln of d by r na. So as m is less, Vd is less. As Vd is less, power loss due to corona will be increases. So due to all this, the power loss due to corona will be increases. Power loss due to corona will be increases. Okay, all of you clear? M is equal to 1 if it is a no irregularity, very smooth surface. M will be less than 1 if it is a irregular or rough surface. Okay, so whenever there is a raindrops fall on that one, then it will becomes less than 1. So as M is less, Vd is less, then power loss will be more. Okay, coming to the next question, guys. Corona loss is less when the shape of the conductor is dash. So whenever the conductor is very smooth surface, then M is equal to 1, which is very high. So then Vd is more, then power loss is less. Correct? So when we will get the smooth surface, whenever it is a circular mode. If it is a circular, then only you can get a smooth surface. So that is circular. Okay. Coming to the next question. Corona loss high in which of the following conductor? Corona loss will be high in which of the following conductor? So here stranded conductor having high corona loss. Stranded is very high. After that solid. After that hollow. Okay. So why? Because in case of stranded, if we twist the more strands to form a single conductor, here what about the irregularity factor? M is very much less than 1. M is less than 1, Vd is less. As Vd is less, power loss due to corona will be more. Okay. So in case of stranded conductors, the power loss due to corona will be more than solid and more than hollow. Okay. So that's why we are going with bundle conductors. So if you go with the bundle conductors, then again corona loss will be somewhat of reduces. Okay. Hollow conductors are mainly used to dash. Just now we have discussed here, due to this hollow conductor, the radius will be increases. As radius increases, Vd increases. Vd increases means power loss due to corona will be less. Okay. So to reduce the corona loss. Here you need to remember the two important formulas. What are those? This one and this one. Okay. Without these formulas, we cannot give the answers for this corona type questions. Okay, corona topic questions. So those two are very important, guys. Try to remember those. The dielectric strength of air under normal condition. So that is 30 kilovolt per centimeter. Okay, generally dielectric strength will be considered for peak to peak value. So it is a peak to peak is 30 kilovolt per centimeter, and if you can consider RMS, that is 21 kilovolt per centimeter in case of RMS values. Okay, in case of peak, that is 30 kilovolt per centimeter. Coming to the next question. Corona loss increases with dash. Corona loss increases with dash. We know the power loss due to corona 241 into 10 power minus 5. Here it is not proportional to directly frequency. It is proportional with the frequency plus 25. So whenever the frequency is 0 also, some amount of power loss due to corona there. Okay, but reduces. Whenever the frequency is less, power loss due to corona will be reduces, but may not become 0. Okay, by delta root r by d v phase minus vd whole square. Okay, v phase minus vd whole square. This is power loss kilowatt per kilometer per phase. Okay, per phase. So increases with the supply frequency. Increases with the supply frequency. And what about the radius? What about the radius or conductor size? As R is more, Vd is more, power loss due to corona will be less. Okay. So as the conductor size is increases, power loss will be decreases. So reduction in the conductor size. Reduction in the conductor size. Okay. As conductor size is more, power loss will be less. So reduction in the current conductor size. Okay. That is, as the reduction in the conductor size, Vd will be reduces, power loss will be increases. Okay. So corona loss will be increases. So as you increase the frequency and reduce the conductor size, then power loss will be increases. Coming to the next question. The corona loss on a particular system at 50 hertz. At 50 hertz, it is a 1 kilowatt per phase per kilometer. The corona loss on the same system with supply frequency is 25 hertz. 25 hertz is dash. We know the power loss due to corona is proportional to frequency. No, frequency plus 25. Frequency plus 25. 25 is the constant is there. Okay. So in this case, if you reduce the frequency is off, power loss is going to be off. No, always some 25 is there. So that means just more than off. Just more than off, they have given one option. So we need to go with the option C. Okay. Or otherwise, you can go with P2 by P1 is equal to F2 plus 25 by F1 plus 25. So P2 is equal to P1 into 1 kilowatt into F2 plus 25. 25 plus 25 F1 50 plus 25. So that is you will get 50 by 75. 25 2s 25 3s 2 by 3 in the sense 0.667. Correct. So the answer is option C. Okay, no need to calculate in detail. So a simple idea, guys. Always some constant is there, so it may not become off more than off. So answer is option C. Okay. If they have given the options are 0.6, 0.7, 0.8 like that, and if you are in the confusion, you can calculate. Okay. The charging current in the transmission line increases due to corona effect because corona increases. What will increase? Corona will be increases. The air around the conductor also ionizes. So what about the effective radius? Effective radius increases now. So that means effective diameter is going to be increases. Okay, effective diameter is going to be increases. Here the power loss due to corona will be dash. Here whenever we have this type of question, simply we do one thing. Okay, what we will do? Power loss is equal to 241 into 10 power minus 5 F plus 25 by delta root R by D and V phase minus Vd whole square, and we are going to substitute the values. But in the starting, what I have given, whenever the operating voltage is greater than disrupting voltage, then only corona occurs. Corona occurs. If V operating voltage less than Vd, then no corona. No corona. Correct. So here what are the parameters they have given? V phase 100, Vd is 105. So V phase is less than Vd. Okay. So operating voltage less than Vd means no corona. There is no chance of corona. So no chance of corona means power loss due to corona will be 0. A very important question. Okay, very tricky question. No need to calculate and wasting the time. Okay, so here the concept is whenever the operating voltage is less than the Vd, no corona loss. Okay, coming to the next question. This one already completed, na? Charging current increases due to effective conductor diameter. The good effect of corona. So we have two good effect. One good effect is nothing but the effective radius is increases. Second one, steepness of surge font is decreases. Surge fonts decreases. What it means? If there is no corona, whenever there is a surges, we may have a steep rise. Okay, without corona, whenever there are surges, we may have steep curve like this. If we have the corona, then the surge may be like this with the corona. Why? Because this amount of surge will may be discharged due to power loss due to corona. Due to corona. Okay, so due to corona, some surge funds is going to be reduced. That is the one more advantage. Okay, so the answer is option D. Okay, coming to the next question. Hollow conductors are used in transmission lines to reduce the corona. Already we have discussed this. The presence of ozone due to corona is harmful because of it dash. So due to ozone, it will becomes oxidization. Oxidization in the sense due to that one, we may get corrodes the material. The material may be corrodes. For good voltage profile under load condition, a long line needs. For good voltage profile, good voltage profile, and also power factor improvement. For all these, we may require a shunt capacitor at receiving end. Okay, a shunt capacitor at receiving end. So due to this shunt capacitor at receiving end, due to some charging current, okay, it serves the reactive component. Okay, it serves for the reactive power. So then we may get receiving end voltage is very much equal to sending end voltage. So it maintains that good voltage profile, and also it improves the power factor. So for those for both, we may go with the shunt capacitor at receiving end. Okay. If the power factor of the load increases, the line losses will be dash. Power factor of the load increases, the line losses will be dash. We know very well power factor, that is cos pi is equal to, we know power is equal to Vi cos pi. So cos pi is equal to power by Vi. Okay. So if the power factor is less in the sense, what about the current? Current will be somewhat of increases. Okay, as the current will be somewhat of more. As the current is somewhat of more, what about the losses? So losses will be increases. The line losses will be increases because of the high current. Okay, coming to the next question. The size of the conductor on modern HV lines is obtained based on dash. I have already given the size of the conductor in modern HV based upon the corona loss. Why? Because due to corona, the effective radius is varies. That means increases. Okay, so due to that, we may get the power losses. So that's why. So as radius increases, Vd will be increases. So power loss will be decreases. Okay. So if you use less radius, then destructive voltage is less, power loss will be more. So that's why design is based on this size of the conductor is based on corona losses. Okay. To meet the reactive power requirements at load centers, usually dash. So already I have given for reactive power capacitors, shunt capacitors are used. Okay. For power factor improvement also shunt capacitors are used. So to improve the power factor, we use shunt capacitors. We use the shunt capacitors. Okay. And to limit the Ferranti effect, what is this Ferranti effect? Whenever the receiving end voltage is greater than sending end voltage, this is called as Ferranti effect. Why this Ferranti effect is caused? Whenever whenever the load is very less, in case of no load condition and or lossless line, there is a chance of receiving end voltage greater than sending end voltage due to charging current. Okay, so if you want to reduce this charging current, we require one device that absorbs that charging current. So if you connect one reactor, okay, shunt inductor or shunt reactor, then it absorbs that amount of charging current. Then we may not get this Ferranti effect. So to limit that Ferranti effect, we can use shunt inductor or shunt reactors. Okay, series capacitors used to get stability. Due to this, the stability is going to be increases, and also you can get voltage control. For voltage control also we can go with the series capacitor. Okay, in the following, which of the device used for voltage control and also stability? Yes, here they are asking voltage control and stability. We can go with the series capacitors. Okay, series capacitors. And which of the device used to limit the fault current? So to limit the fault current or such current, we can go with the series reactors. These can absorb some amount of the fault current. So that's why the fault current will be reduces. Okay. So let us take a small idea about this shunt capacitors. Where we are using shunt capacitors, voltage profile and power factor improvement. Okay, in the same way, series capacitor to improve the stability and for voltage control. Okay, and shunt reactor or inductor. Shunt reactor to limit Ferranti effect. So many students having confusion in this. So if you take like this, then you will get a clear idea. Series reactor to limit fault current. Okay, to limit the fault current. Okay, all of you clear? Coming to the next question. Which of the following must be decreased to increase the capacity of a transmission line to transmit the power? Okay, power P is equal to EV by XS sin delta. Okay, so if you want to increase the capacity, we need to decrease the excess. Okay, excess in the sense we need to decrease the inductance. So if we decrease the inductance, we can get power capacity will be more. Okay, coming to the next question. A load power factor of 0.95 lagging implies reactive power demand of dash. Okay, a very important question. Here, reactive power demand in terms of kVAR per kilowatt they are asking. kVAR per kilowatt. We know the power triangle. Okay, so S, P, Q. Q is the reactive power. So kVAR per kilowatt. So P is kilowatt. This is kVA. This is kVAR. So how to get kVAR per kilowatt? Tan pi na? Tan pi is equal to Q by P, that is kVAR by kilowatt. So we need to calculate this one. Okay, we need to calculate this one, that is tan pi. Tan pi. So what is the pi? Pi is nothing but cos universe tan pi, cos inverse of pi. Okay, power factor is equal to 0.95, that is equal to cos pi is equal to 0.95. Pi is equal to cos inverse of power factor. Okay, 0.95. So that is tan of cos inverse 0.95. Okay, 0.95. So that means here you will get cos 90, cos 0 is equal to 1. Okay, so that means here less than some value means more than 0. Okay, cos 30 is equal to you know very well 1 by sorry, cos 30 is equal to root 3 by 2. Okay, so that means here you will get approximately 0.33. So this is the 0.33 kVAR by kilowatt. So the answer is option C. So the answer is option C. Okay, all of you clear? A very simple question. They are asking reactive power demand of kVAR per kilowatt. This is the kVAR. This is kilowatt. So that means Q by P we need to find out. Q by P is tan pi. Okay, tan pi. Pi is nothing but cos inverse of power factor. Cos inverse of 0.95. So if you calculate this one, you will get approximately 0.33. 0.33. Okay. Coming to the next one. Which of the following equipment has the lowest power factor? Lowest power factor. Okay. So lowest power factor, it may be highly inductive. So in case of arc lamps, we may get very low power factor. Very lowest power factor. Okay. Coming to the next question. The active and reactive power of inductive circuit are 60 watt and 80 var respectively. So here they have given 60 watt, 80 VAR respectively. Then what is the power factor? What is the power factor? Okay, a very easy question. Power factor is nothing but cos pi. That is nothing but 60 by. So it is the 60, it is the 80 means it is the 100 na. Okay, S is equal to root of 60 square plus 80 square. So you will get 100. So cos pi is equal to 60 by 100. That is equal to 0 0.6. 0 0.6. Okay, so the answer is option B. Answer is option B. A very easy question. As the power factor is high, then consumer maximum kVA demand is dash. Power factor is equal to VI cos pi. So kVA in the sense this is the kVA. P is equal to S cos pi. Okay, S cos pi. So here they are asking power factor is high. So S is equal to P by cos pi. So as power factor is high, S is less. Correct. So it requires less demand. So answer is option D. Answer is option D. Coming to the next question. One BOT. Okay, board of trade is nothing but one unit is nothing but 1 kilowatt hour. 1 kilowatt hour, that is also considered as one domestical unit, one electric unit. Okay. Okay, students, we will discuss the remaining questions, that is cables based questions, in the next session. Okay, and students, if you want to download the PDF, you can visit sunilengineeringacademy.com. In that you will get a 1 minute video, that is how to download the PDF. Okay, watch that 1 minute video, then you will get the idea how to download the PDF, and where you will get the downloads option. Okay. Okay students, if you like my classes, please encourage me with click on likes, and also please share to all your friends and encourage me to make more videos. Okay. Okay students, thank you so much, all of you.